Okay, cloud gurus, the cluster autoscaler. All about right-sizing your cluster for your apps, and it's pretty sweet actually. Only, I guess out of necessity really, but it's pretty tied into your underlying cloud platform. And you'll see this when we look at the demo in a minute. It's going to be a bit Google Cloud specific, but even if you're not on the Google Cloud, right, you'll still get the overall picture. Anyway, you build your cluster with auto scaling enabled, and I'm guessing all of the hosted platforms these days have it by default. Though, don't take my word for it, definitely check your cloud's documentation. But you enable it on a cluster and you configure pools of like nodes. Just groups of identically spec nodes, yeah? So, like an auto-scaling group or something, but provided by your cloud's hosted Kubernetes service. And that's important. It's not just any old scaling group on your cloud. These are tied into your cloud's Kubernetes service. And you can have a bunch of them if you need, like if you need different sized nodes and the likes. But you have a node pool and you give each one a maximum and a minimum value. Maximum's the most nodes it can have and minimum's the least. And that's your cluster ready. After that, you configure your app. And that's normal stuff, right? Deployments, daemon sets, all the usual Kubernetes stuff. Only you absolutely have to configure your pods with resource requests. Let me throw up a warning and sound the klaxon. Cluster auto-scaling only works if you configure your pods with resource requests. Because check this out, the way it works is that when scheduling a new pod, Kubernetes looks at the resources it's requesting and it sees if there's a node on the cluster that can take it. And when it's looking at the cluster, it's not looking at what's actually in use. No. It's looking at what's been collectively requested across the cluster. So, I mean, your cluster could be doing like literally nothing, not stressed at all. But if you've scheduled a ton of pods with resource requests, even if none of them are doing anything, Kubernetes might consider your cluster full and mark new pods as pending while it waits for a new node or something. Now, in reality, it's going to be an HPA that triggers the new pods. And HPAs are different. They do work on actual observed metrics. So, I mean, it's unlikely that your cluster's going to be idle, certainly if the HPAs trigger new pods. Either way, though, there is a potential loophole there. So a proper pro tip, try saying that, eh? Well, it's a pro tip to schedule all of your pods with resource requests. And a similar gotcha, right? If you don't schedule your pods with resource requests and your cluster's being ran into the ground, tough luck. No resource requests, no scaly. So for auto-scaling to work properly, you've got to do everything else properly. Anyway, what else? Okay, so the cluster autoscaler wakes up every 10 seconds. That's when it checks for pending pods. Obviously, it can grow and shrink your cluster, but it's got a few checks and balances built in so that it's not overreacting to like every twitch in the cluster. For example, one of those is wait 10 minutes before removing a node, yeah? So even if a node might be idle and there might be space elsewhere in the cluster for its pods, before going ahead and turning it off, the cluster's just going to watch it for 10 minutes first, just in case circumstances change, yeah? Well, obviously it works alongside the horizontal pod autoscaler. I think I already said that. But as HPAs add pods, if any of them go pending due to insufficient node resources, the cluster autoscaler kicks in and grows the cluster. And then, I guess just a couple of warnings really. First up, don't try and manually manage the pods in an autoscaling pool. You'll just end up fighting with the cluster autoscaler, and believe me, that thing never sleeps. So just leave it alone. And as well, different clouds, they offer different levels of support, right? Traditionally, Google's been the best at supporting the scaling APIs, but that's not to say that others aren't up in their game. Oh, yeah. And on really big clusters with node affinity rules, do a bunch of testing first, okay? Because you might experience performance issues. I mean, like auto-scaling literally grinding to a halt. So do your homework if you've got a big cluster and you're using affinity rules. But that's the theory. Plan your nodes with resource requests. I should say containers really. It's the individual containers that have the resource requests. But containers live inside of pods and they all get rolled up to the pod that owns them anyway. But if you're doing that right, resource requests, and you've got auto-scaling enabled on the cluster, things are going to dynamically scale with the needs of your app. Bingo. Well, let's see it in action.